Aloha, everybody. This is Gigi from Kauai Community College. Again, we are going to go over volume by shells in this video. If you haven't seen this yet, look for my previous videos before this one, okay? Suppose you are looking for the volume of the region bounded by the sideway parabola, y squared equals x minus 1, the vertical line, x equal to 2, and you are going to rotate that region about the line y equals -2. So go ahead and pause the video. Take a try at graphing, okay, and find out the region before you watch this. All right, now once you've done that, you should get this looking shape here. That's the region that we are going to rotate. Let's remind ourselves here that we are rotating about the line y equals -2. So there's another copy on the other side, right? And did you see that? That gives it a three-dimensional effect. I really like that. Let's do that again. There you go. Now that's three-dimensional. Okay, so then the parabola here is y squared plus 1 equals x, and the vertical line is x equal to 2. This line right here, the axis of rotation is y equals -2. Okay, now in order to find a volume by shell, you are going to go ahead and take one strip, a rectangular strip right there, then rotate it to get a cylindrical shell. Okay, and then you're going to open it up into a rectangular prism, right? We've seen that before. So let's go take a look at the height of that. That would be from here minus here, right? Here would be x equal to 2 minus y squared plus 1. So 2 minus y squared plus 1 is 1 minus y squared. That's the height of that rectangular strip, which is the height of our rectangular prism once we open it up. Okay, and then the radius is what we also will need. And the radius go from the y value, right? So the y value right here minus 2 right here. Okay, minus a -2 actually. So that would be r equals y plus 2, right? Okay, now let's take a look at that rectangular prism. Again, the height is 1 minus y squared. The length of that would be your circumference with radius y plus 2. Okay, so 2 pi r. And then the thickness of that is delta y. So then the volume of one shell is 2 pi times y plus 2. That's the area, that's the circumference there. Multiply by 1 minus y squared. That gives you the blue area on top. And then you multiply by how thick, and that gives you volume. Okay. With that one piece, with that one shell, we're going to go ahead and do a summation of a bunch of shells. And then we're going to take the limit as n goes to infinity, which we then define an integral. And the integral will go from -1 all the way up to 1. Okay, that's the limit of our integration there. And then if we multiply out this part right here, that's what we have. And then the thickness is delta y. So we are integrating with respect to y. All right. Once you do the math, you should get 16 pi over 3. So check my work, make sure I'm correct. Okay, let's take a look at another example. The region is being bounded by the line y equals x, the parabola y equals x squared, and it will go from 0 to 1. Okay, let's go ahead and take a drawing of that. And it looks like that. You are going to rotate at about the y-axis, okay? to make a solid. And I'm going to go ahead and do that. And again, that three-dimensional effect here, that's the shape that we want, right? So we are going to shell this. And to shell that, we are going to take a look at one rectangular strip. The height would be x minus x squared, right? Because this right here was y equals x, and this right here is y equals x squared. Okay, so the height would be x minus x squared. And the radius is going to be just the x value right there. Okay, the thickness is delta x. So then we know that the volume would be an integral with respect to x. And so then it would go from 0 to 1. That's our limit of integration. So setting up volume 0 to 1, 2 pi r multiplied by the height. And then we are going to integrate with respect to x because that's the thickness delta x. Okay, now let's do some simplifying, taking the 2 pi, the constant outside of the integral, evaluated from 0 to 1. We should have the volume is pi over 6 cubic units, whatever that unit might be for you. Okay, now what we want to also do, because when I'm looking at shapes like this, I am dying to just use slicing. So let's look at the same volume, but use the slicing method to see which one you like better and how your brain works. Like I naturally just go with slicing rather than shells, right? So I'm not sure. I think it's because of my three-dimensional ability to think of it as three-dimensional shell. It's kind of not so well-versed yet, right? That's the key word. If I do so many of these, maybe I'll get better. All right, so let's just take a look at slicing. Let's do it by one slice. Okay, the thickness is delta y. Okay, and then when you are slicing, you're going to have a cross section and it looks like that, right? The inner radius is from the y-axis here out to this part. So the small radius we would say is the x value of that line. And since y equals x, we can just reverse that and say x equal to y. And then the outer radius, the bigger radius there, is going to be the x value of this equation here. Solving for x, you would have x equal to square root of y. Okay, so let's put a label on there. Little r is y, and big R is square root of y. All right. And how do we do this again? By slicing, first we need to look at the area of the cross section. And that would be pi r squared, that's big R squared, minus pi little r squared, right? The blue minus the purple circle there. Okay, clean that up a little bit, factor out the pi. Okay, I would have that. Now to find a volume, I would multiply by how thick, which is again dy, and then I would sum up a bunch of circular discs here. Actually circular washers because it's empty in the middle. And then I am going to take the limit as n goes to infinity, would set up my integral. And my integral will go from the y value of 0 to the y value of 1 right there. And so the volume of the solid is the integral from 0 to 1 of the area of one slice multiplied by how thick, right? Area multiplied by how thick, that gives you the volume. And so doing some integration, evaluate that from 0 to 1, plug in the 1, I have that, and the final answer would be pi over 6, and that's the same answer as before. So again, same problem, two different ways. Which one do you like better? Always think about what you have. Okay, so by slicing or by shell, do I integrate that with respect to X or with respect to Y? And then here's a little graphic for you to kind of put your thought in process as far as which method is good when you are looking for volume. And that is it for right now.